All right, my pre-calculus children, I am missing you and I hope you're doing well, and I'm going to look today at some extra practice problems from section 11.1. So we kind of eased our way into it. We had a 3-day introduction so that you'd kind of get your feet wet with this. It's a little bit odd, these trig identities, but again, it's important for us to be able to get to being able to solve trig equations, which is where we're eventually going to go. So these are some extra practice problems. You should have seen enough examples at this point where it gives you some ideas as to how you might try to treat these questions. But at this point, number 3 is the first one I want to do with you. And I want to break this up first so that I have each trig function in its own separate place. So this will be the tangent, and this angle is calling alpha this time, kind of like the fish. It's times a cotangent of alpha. And then it's times 1 over cosecant of alpha. See how the cosecant's in the denominator? So I want to say that. I want to continue that in the same mode. So then I'm looking at this. I have tangent, I have cotangent, and I have 1 over cosecant. And I'm thinking about all the identities that we had listed on the very first day that we talked about the trig identities. So I have 2 choices for tangent. I can call it sine over cosine. I can call it 1 over tangent. Both are correct. I like to change things into sines and cosines most of the time. You can do it a couple different ways. There's not one exact way to do these. We still in the end should end up with the same answer though, if you're looking at simplifying this. So sine over cosine, cotangent is cosine over sine, and 1 over cosecant is the same thing as the sine. It's reciprocal with the sine. Oh, it's an alpha. All right, let's see what happens. So if I take the cosine on the bottom, cancels with the cosine on the top. The sine on the top cancels with the sine on the bottom, and I'm left with just a sine of alpha, and that's my final answer. Now some of you might have thought to take tangent and turn it into 1 over tangent, and then leave cotangent as I'm sorry, 1 over, this should be 1 over cotangent. 1 over cotangent. If I were to do that, some of you might have thought to do that, times the cotangent that you got there, they cancel each other out just like we did, and we'd still end up with the same answer of sine. So more than one way to do the problem. In the end, the answer should be equivalent either way. All right, here's the next one I want to choose to do is number 7. Number 7 is a little bit more dicey. So let me show you how the deal goes with number 7. You can choose to work on the left, you can choose to work on the right. And this one is now a verifying problem, so they're telling you the answer. And they're never going to tell you to verify something that doesn't actually verify. They're not going to trick you. So I can choose to work on the left, I can choose to work on the right. I think right now what I want to do is see what the right hand side does. So I'm going to leave the left as 1 plus the secant, we're in thetas now, over tangent of theta. I know cotangent is the same thing as cosine over sine, and I know cosecant is like 1 over the sine. And that makes me kind of happy because they've got common denominators. And if they have common denominators, I can put them together. Cosine of theta plus 1 all over the sine of theta. And you can see I'm kind of at a stuck point now. I'm not sure what quite to do with that. There's no squares involved. It just is that. So I'm going to go and work on the left a little bit. On the left, I know that secant is 1 over cosine. So I've got 1 plus 1 over cosine. And I know tangent is sine over cosine. And I just made that look way messier than it did before, which is never a good thing, right? So what I'm going to do is think horizontal. This is a complex fraction. So I want to think about dividing them, but putting it horizontally. So I'm going to do it as 1 plus 1 over the cosine of theta divided by the sine of theta over the cosine of theta. And when I simplify that, supposedly I'm going to get this, cosine of theta plus 1 over the sine of theta. Certainly not there yet. All right, I want to add these two things. There's a fraction involved, so I have to have common denominators. Common denominator between a 1 and a cosine is a cosine. This one has a 1, it needs the cosine, so I need to multiply this by cosine of theta over cosine of theta. That's going to give me a cosine of theta on top. plus 1 over cosine. And I'll keep it divided by for now. Sine over cosine is supposed to equal cosine of theta plus 1 over sine of theta. Do you really need to write this every time? And the answer is yes! You're trying to do a proof. You're trying to prove something, so you've got to show each time that you're trying to make it equal to the other side. All right, on the left, I have common denominator of cosine. I have a cosine of theta plus 1 on top. That's this whole parenthesis thing. I'm dividing, so I'm multiplying by the reciprocal. Does it really equal this? I don't know quite yet. Let's see, one more step. This cosine on the bottom cancels with the cosine that's up on the top there. Top and bottom cancel. And so I am doing a happy dance because I can see that the cosine of theta plus 1 over the sine of theta is on the left. And I've got the cosine of theta plus 1 over the sine of theta on the right. And I have just verified that that is a true statement. Number 8, there's a typo. They should all be the same values, whether it's thetas or x's, so change this x to a theta. Forget about the x. Number 9 is another one that I want to look at with you. Number 9, if I think reciprocals, 1 over cosecant is the same thing as the sine. 1 over cotangent is the same thing as tangent. And I'm supposed to make them equal to cosine. All right, so sine, I'm going to divide this up, I'm going to break it up. Sine of x times 1 over the tangent of x. Sine's in the numerator, tangent's in the denominator, and that's all I'm saying. I'm just breaking it up. And then I have the sine of x I leave alone. I normally don't change sines and cosines. 1 over tangent is the same thing as cotangent. Does that really equal the cosine of x? I don't know, let's check. If I take the sine of x, again leaving it alone, cotangent, I have two choices, 1 over tangent, that didn't get me anywhere, or cosine over sine. And this is a sine in the bottom, this is a sine in the top, and I get cosine of x equals cosine of x. So when they give you this crazy complex fraction, just simplify the numerator and simplify the denominator, and you'll end up in a pretty good place. All right. Just a few more to go. Number 10 is next on my list. And I'll be honest with you, I don't know what this angle is. It's a U, it's some Greek letter. Not quite sure. But you can call it X, you can call it whatever you want. It's really not that big a deal. If I look at what side is more complicated, because that's normally where you want to start, the left-hand side looks a little more complicated because you've got some multiplying things going on. So let's start on the left and see where it takes us. I'm just going to call this a U. Cotangent of u times 1, I'm distributing cotangent for each of these things. So I've got cotangent of u times 1 is cotangent of u. Cotangent times sine is cotangent of u sine of u. And supposed to equal, I'm going to go into the next box just because of space, cotangent of u plus cosine of u. All right. Let's see with this thing. If I change this into sines and cosines, which is normally what you want to do with these, on the left-hand side I'm going to have the cosine of u over the sine of u. I'm going to have this one, this cotangent is going to be the same thing, cosine of u over sine of u. And then it's times the sine of u. And all of that is all my left-hand side. I haven't done anything to the right. I'm going to leave the right cotangent of u plus cosine of u. All right. I can see this doesn't do anything. I can't simplify, cancel anything out right there. It's a single term. But over here, my sines actually cancel out. I've got one on the bottom and one on the top. And so this really equals a cosine of u. So I'm going to put my plus sign. I've got a cosine of u. And look at what you're trying to make it match. You're trying to make it match the cotangent of u plus the cosine of u. And you can see you got the plus cosine of u, you need a cotangent. Well, actually, cosine over sine is cotangent. We switched it, but we're going to switch it back because that's going to be our identity. That's going to verify us that we've got the cotangent of u plus the cosine of u on both sides. All right, the next dicey one that I see is number 13. And if I'm looking at number 13, the left-hand side for sure looks more complicated than the right-hand side. So if I'm looking at this thing and I'm thinking about how I can fix this, on the left, tangent can be sine over cosine. And I'm going to actually leave this the way it is. Cosine squared theta plus 1 over the sine of theta is supposed to equal the cosine of theta plus the secant of theta. Let's see what happens. I end up with the signs canceling, top and bottom. And so now what I have on the left is the cosine squared theta plus 1 over the cosine of theta. And on the right, I'm not changing anything yet. I'm not doing anything over there yet. Well, I can see over here I've got cosines. I'd kind of like to cancel them, but I can't. But I can separate this because it's a single denominator. We saw that in day 1's notes. If I have a single denominator, I'm allowed to split it. So if I do that, it's going to be cosine squared theta over the cosine of theta plus 1 over the cosine of theta. Again, it's supposed to equal the cosine of theta plus the secant of theta. Let's see how this reduces. If I have 2 cosines on top, cosine squared, and I have 1 on the bottom, this 1 can cancel with that 1, and I'm left with a cosine of theta. That's up top because that's where the bigger power was. 1 over cosine is secant. And that makes me quite happy because look what I have on the right hand side that I'm trying to make it verify to equal, and it is right there done. All right, last couple problems. They're going to have you multiply in these next set, and they're then going to have you factor on the last set. So this one, 16, is the biggest beast between 15, 16, and 17, so we'll take this one on together. If I FOIL, literally I'm just foiling, and I'm going to go into my boxes because it's going to get kind of big. So I have cosecant of alpha times cosine of alpha. Cosecant alpha, cosine alpha. They're my first terms. My outer terms are going to give me a plus cosecant alpha times the sine of alpha. That's these guys, the outers. The inners give me a negative secant of alpha and a cosine of alpha. And the lasts give me a negative times a positive is a negative secant of alpha, sine of alpha. I kind of go cursive. Have you noticed that? I go cursive and print it all at the same time. All right, sine of alpha. All right, here's your next step. You want to turn everybody into sines and cosines like you would. So cosecant is 1 over the sine times cosine plus cosecant is 1 over the sine times the sine. Secant is 1 over the cosine times cosine. Secant is 1 over cosine times sine. Well, this would be 1 times cosine over sine. Next one, my sine has 1 on the bottom, 1 on the top, so I can cancel them, so plus 1. Cosine, 1 on the bottom, 1 on the top, can cancel them. And then I get 1 times the sine is the sine, and cosine's on the bottom. Well, the 1's cancel, so I'm done with those. And then I'm left with cosine over sine. Well, that's cotangent. Sine over cosine is tangent. And that's my final answer for number 16. So it took a lot to kind of FOIL that out, but it came out to be pretty nice in the end. All right, if you flip the page, I'm going to show you a factoring one. I think you saw factoring in one of our day applications in day 1, day 2, or day 3, one of them. But here's the story when you get these crazy things and they want you to factor. First thing you got to check is make sure you've got the same trig function. If these were different trig functions, you'd have to do extra doodaddies to it to make it work. But for this one, they're the same trig function. So all I'm going to do is I'm going to pretend that cosecant is really just an x. So I'm going to pretend that this is 2x squared minus 5x minus 12. 2 cosine squared x squared minus 5 cosine x minus 12. And the reason I do this is because we know how to factor that very easily. Back in the day, it's the AC method, right? So I've got 2 times negative 12 is negative 24. The factors of negative 24 that add up to be a negative 5. You got negative 8, you got positive 3. Then you've got to divide by the leading coefficient of a 2. Negative 4 and 1. This guy doesn't reduce. I'm doing this fast, but I know that you know what I'm talking about. So if I were to factor this, it would be x minus 4, bottom to top, and 2x plus 3. If it were back in the days of Algebra 1 factoring, but it's not. This is now really a trig function, so all you need to do is replace your x's with a cosecant, and then you're talking our pre-calc trig language. Alright, so I have, instead of it being an x, it's cosecant of x minus 4 is my first group. Second group is 2 cosecant of x plus 3, and you've just factored that. That's it, you're done. Alright, so factoring is treated the same exact way it was back in Algebra 1, Algebra 2, whenever you learn this, and you just are replacing it with the trig functions that we're talking about in pre-calc. Alright, so your job is to complete the rest of the problems from numbers 1 through 20 of the practice problems for section 11.1, and we'll talk again soon. Hope you're doing well. Bye.